You can see that we have a very simple UI to upload our videos. I already downloaded some duty-free videos. One of them is like this, very simple. Some woman is walking by the sea. I'm gonna upload this one. Let's go ahead and upload it, and then it will extract the frames. Our interval was 5 seconds, so this one was 30-second video almost. Let's see the frames. It should be 4 or 5 of them while the video is being uploaded and processed. Yeah, as you can see, the frames are extracted. 1, 2, 3, 4, 5, 6. So now our prompt contains 6 different images, and the LLM is being asked to summarize this video. Let's go back to the browser and wait for the processing. It's gonna take a while. It's a heavy job. Okay, perfect, it's done. The answer is, the video features a woman standing on a rocky beach facing the ocean at dusk or dawn. And then about the clothes, she's wearing a white dress. And it's even saying like there is a sense of solitude and contemplation in the video. And it's saying that it has a cool blue tones in the video as well, which has a mood of peacefulness and mystery. Hey everyone, Nariman here, welcome to my channel. Today we want to create a video summarization app using Gemma 3. As you might know, we have some LLM models that understand only text, and then we have some vision models that are built to understand images. And then we have some models that understand both of them very good, like this new Gemma 3, which is Google's open source model. You might also know that videos are mainly created of frames, which are distinct images, and they are being shown to you very fast. Like usually the frame per second is 30, which means that in 1 second you are seeing 30 images which are distinct and they are continuous. So if your model is something like Gemma 3, which can understand images very good, you can extract some frames from the video, just sample a bunch of them because processing all the frames in a video would be too much. And then if you pass it to Gemma 3 and ask for a summarization, it can tell you what is going on in that video with a very good precision. So with that in mind, let's start coding. First, let's start with the dependencies that we are going to use. We are going to use a Streamlit to create a very simple UI. And then we are going to use LangChain related dependencies to talk directly with Ollama, because Gemma 3 is available through Ollama. And last but not least, we are using OpenCV Python. OpenCV is a very famous computer vision library. We are using it in terms of extracting frames from the video. So to install all the dependencies, you can go to the command line and make sure that you are in the projects directory, then install everything with the pip command. Install -r, and then your requirements.txt file, hit enter, and done. One other thing, I mentioned that we are using Gemma 3. I am using the one with 27B parameters. Make sure to install Ollama on your local machine, and then to have this model, you need to type Ollama pull and Gemma 3, and then enter your preferred version. As I told you, I'm using 27B, so it should be like this, but bigger models need more powerful machine. So feel free to use something like 4B if you don't have that strong PC or laptop. Yeah, I don't need to run this since I already pulled it, but make sure to do it if it's your first time pulling that model. So let's go back to the code. I already created a project structure. So user will come and upload the video. We are gonna go and save it in the videos directory, which I already created here. And then we are gonna extract some frames with our preferred interval. And then we are gonna save those frames in this directory, which I created here. Then I'm gonna ask Gemma 3, here are the images, describe to me what is happening in this video, which is gonna happen here in this describe video function. So let's go and start coding the logic here. Gonna collapse this one. Uploading video is just basic Python working with files. So I'm gonna open this file for writing, and then I'm gonna write it to the file. That's it. But extracting frame is a bit more complicated. Here is where we need OpenCV. So as parameters, we are gonna get the video path, which we saved here, and we are gonna get some interval seconds. This will control the size of our samples. For example, the default here is 5. So I'm saying if a user uploaded a video, every 5 seconds, store a frame. This is very good for a short video. For example, if it's gonna be 30 seconds or something, it's gonna store 5-6 frames, which is good enough for the LLM to know what is going on in there. And it's also not a huge amount, which requires a lot of machine resource to process them. But if someone is gonna upload a movie, like if you're gonna upload Godfather, which is like 3 hours or something, and then ask the LLM to process this for you, every 5 seconds it's a lot. So there will be lots of frames to process. So then you can increase this interval to store less frames. Now that we know this, let's first clean up the frames directory, because the user will come and upload one video, and then when it's gonna upload the next one, there are still frames of the previous video in there, which can mislead the LLM. So let's, every time that we are calling extract frames, clean up the directory. I'm gonna use os.listdir in Python for file in os.listdir, and then frames directory. This will list all the files and directories inside this frames directory. Since we are already sure that there is not going to be any directory in there and everything is file, I'm not going to check the type. I'm just going to say os.remove and then frames directory with the file. So this will clean up the whole directory before we move on and store new frames in there. That's it. Then I need to load the video using OpenCV. So it's CV2 video capture, and then I'm gonna give the video path, and this is going to be my video. Let's also calculate frame per second. As I mentioned before, each second the video is showing around 30 or 60 frames. So we need to read that from the video.get, and then in the properties, FPS. Let's also read the frames count, how many frames we have in total. It should be something like, yeah, frames count. If you have a look, this function is returning float. You can go ahead and just round it up, like convert it to int. It would be better and more precise. So what I need now is to have a loop to iterate through the frames and then store the ones that I'm interested in. So we should keep the current frame where we are. Which is a number. At first it should be 0. Let's also count how many frames we are storing to use it as the file name. Like this is frame 1, this is frame 2. This is better to start from 1. And the loop is basically a while loop. While the current frame is still smaller or equal than frames count, our total number of frames, what we should do? First, we need to move the video to that frame. So it's like video.set, and then CV2, there should be something like position, yeah, for frames, position of the frame. And this should be our current frame. So we are moving the video to the frame that we want. And then we need to read that frame. And if you look at this, it is a tuple of Boolean and a CV2 type. So the first one is the result. Is it success or not? And the second one is our frame. So I'm gonna say if success, or if not success, there was a failure, let's just continue, go for other frames, let's just ignore this one. But if not, let's write it to the disk. Let's create some paths for our frame. Okay, it should be in the frames directory. And then let's call it, I don't know, frame underline, then our frame number, and let's give it something like a 3-digit format. And the format can be JPEG. So for example, for our first frame, it will be like frame underline 001.jpg. Then we go back to the CV2 and we want to write this file. This is the frame path, and this is our frame that we want to store to the file. Then we need to increase current frame and frame number. But we don't want to say current frame plus 1. We don't want to go to the next frame. We have a interval seconds, and we know the FPS. So 1 second has the amount of FPS frames. If the interval second is 5 or 10, then we need to move interval seconds time FPS forward. So for example, if our interval seconds is 10 seconds and FPS is 30, we need to ignore 300 frames and then read the next one. So every time we are going forward FPS time interval seconds. And of course the frame number we are just gonna increase by 1. At the end, it's better to release the video. It's a resource that we allocated. And that's it. It was a bit complicated, but I think we managed to write it in a simple and readable way. To describe the video in this method, first we need to load all the frames. So let's have a list of the images or frames. And again, let's use os.listdir to list all the files and directories inside frames directory for file in os.listdir, and then frames directory. Let's append all the images that we are loading, but only the paths. So it will be this file. So these images will contain all the paths to frames, like frame 001, frame 002, as much as we have. Then notice that I defined our model here. It is an Ollama model, and as I mentioned, it's Gemma 3 with 27B parameters. So we need to use this model to bind these images to it and then send the prompt. So if we come here, I'm gonna say model.bind, and then it has a parameter called images. I'm gonna pass our images to it, and then I'm gonna call it something like model with images. Then we need to invoke it with our prompt. I'm gonna just use a very simple prompt, one-line prompt, but you can make better prompts out of it. Let's just try summarize, yeah, the video content in a few sentences or in a paragraph. That should be enough. And we can return this response. And that's it. We are done with the logic. Let's also create a very fast UI for it. It's very easy. Like, I already created this file uploader that says to the user, upload this video, and then you can restrict which types of video it can be uploaded. And I said you cannot upload multiple files. And then I'm gonna say if there is an uploaded file, just upload the video. Then let's extract the frames. It can be with our new video, and then easily just call describe video. And this will be our summary. This is something that we need to show. You can say st.write or st.markdown because usually LLMs respond in markdown format. So I'm gonna show this summary here. That's it. So this will be our simple UI. We are basically done. So let's go to the terminal again and see if everything is working. I'm gonna say Streamlit, run, and then our Python file. Okay, let's hit run. Let's go to our browser, and perfect. You can see that we have a very simple UI to upload our videos. I already downloaded some duty-free videos. One of them is like this, very simple. Some woman is walking by the sea. I'm gonna upload this one. Let's go ahead and upload it, and then it will extract the frames. Our interval was 5 seconds, so this one was 30-second video almost. Let's see the frames. It should be 4 or 5 of them while the video is being uploaded and processed. Yeah, as you can see, the frames are extracted. 1, 2, 3, 4, 5, 6. So now our prompt contains 6 different images, and the LLM is being asked to summarize this video. Let's go back to the browser and wait for the processing. It's gonna take a while. It's a heavy job. Okay, perfect, it's done. The answer is the video features a woman standing on a rocky beach facing the ocean at dusk or dawn. And then about the clothes, she's wearing a white dress. And it's even saying like there is a sense of solitude and contemplation in the video. And it's saying that it has a cool blue tones in the video as well, which has a mood of peacefulness and mystery. So amazing. As you can see, Gemma 3 is very good at processing images, and in our case, videos. It can even capture the tone and the mood. I hope you enjoyed watching this video. Please like it and also subscribe me for more content like this. See you around.